Welcome to the first lecture, everyone. We will start with descriptive data. Descriptive statistics are probably the first thing that you do, whether you're working on Excel or IBM SPSS or any other platform. And as the name suggests, it is just numbers that describe a data set in terms of the important features. Now, even though we refer to types of data as categorical, which is qualitative, or numerical, which is quantitative, and a third type, which is ordinal, which are numbers, but they are categories. For example, ranks between 1 to 5 or strongly agree to strongly disagree. In Excel, most of the time you would be working with numerical data, unless maybe you have some research or some survey data where you might have ordinal data with you. The topics that we're going to cover include standard deviation, which is extremely important. And we will also focus on skewness and kurtosis, and we will see how these measures of variability can help us interpret the data better. Here we have a simple data set with some sales transactions, and we have 100 records with us from A4 till A103. Now, if we wanted to, we could have got all the results using inbuilt functions. So let's do that. To find the average, we simply write equal to average. I will write the formulas here as well. To find the median, we can write equal to median. Median simply means that there are 100 values, and if I apply a filter and sort the numbers, the value at the 50th and the 51st position, which means this area, that would come as 62. Obviously, for the median to be calculated, the data will have to be sorted. The advantage of finding the median is that it is sometimes a good representation of the data because it is not impacted by extreme values. Similar to this, we have the mode, which simply tells us which sales amount is appearing the maximum number of times. In this case, 19 is coming the maximum number of times. Now we come to the main thing. We come to standard deviation. We select standard deviation of a sample, and all you have to do is to select column A, and it gives you 428.28. We will look at the derivation in a bit, and I will explain how this number is calculated and what significance does this number have. To find out the variance, we can look at the standard deviation multiplied by itself, which is square. And then let's quickly do the others as well. We have kurtosis. Then we have the skewness. After that, we can look at our maximum. We can look at our minimum. And then we have our range, which is max minus min. And of course, we have our count as well. This would simply be the count of observations. Let's quickly look at the derivation of standard deviation. And after that, I will show you how you can get all these results in a single click. The way standard deviation works is that you first have to take the average of the complete list of values, which in this case is 214.5. And if I subtract each value, in this case A4 minus the average, we get 46.5. which means that when we drag it down, these numbers refer to the difference from the mean. For example, the first record is 46.5 from the mean, the second is 516.5 from the mean, and the third one is 200 less than the mean. All we have to do here is to simply drag it down like this. Now, if we simply find the sum of all these numbers, it is going to result in a zero, which doesn't really make any sense because the numbers get cancelled. That is the reason in standard deviation we have to find the square of this value. And once we do that, all these numbers become the squared differences. That is why it is called the sum of squares. After this, we can simply find the sum of these squared values. And once we have done that, we can divide it by 99. Since 100 is the number of observations, we do n minus 1. And then once we find the square root, this gives us nothing but the same number that we have here. What we have in C7 is how we have calculated it using these 4 steps. And what does standard deviation signify? Standard deviation tells us that on an average, each value is 428 from the mean. So if we go back to the slide in the presentation, let's look at this example. As you can see, the average of both these data sets is exactly 100. So the blue and the red data set is 100. But the standard deviation for the red is 10 and the standard deviation for the blue one is 50. That means that the blue data set is more spread out, where the numbers are wider in range, which has more small numbers and more large numbers, while the standard deviation for the red one is more narrow, which means the numbers are between 70 to 120. We will do one more example in which we will compare two different regions and try to see what significance the standard deviation has, especially when you keep it alongside the mean, which is the average. All right, now how do we get these numbers in a single click? To do this, let me also save the file. To do this, we have to enable something called data analysis. This is in the data tab. Now you might not see this on your system. You have to enable it one time. To do that, go to File, Options, Add-ins, select Excel add-ins and click on Go, and select the Analysis toolbar. If you're wondering why this has been not enabled by default, even though it is installed, it is because Excel assumes that most regular users would not need or have the capability of working with statistics, which honestly I find a little ironical because they have given all the functions, but they have disabled this button. But now we know how to get it. So we click on this. And as you can see, we have several options available here. We have analysis of variance, correlation, covariance, descriptive statistics, exponential smoothing, F-test, Fourier analysis, histogram, moving averages, random number generation, rank, percentile, regression, sampling, and different types of t-test and z-test. We will select descriptive statistics, click on OK, and our input ranges from A3 till A103. And since the first value in A3 is a label, we have to select label cell. The output range, I'm simply going to select on the same sheet. Let's say in L4, and we will select summary statistics. There is also an option for the kth largest and the kth smallest that we're going to leave out, and for the confidence level. Now, understanding the confidence level is outside the scope of this course, But if you are curious and if you want to have a look at what it means, you can simply type confidence level meaning, and you can see that 95% confidence simply means that, in a very simple language, that the true mean of the population, which means if you do a test 100 times, 95 times the mean will come as the actual mean. Let me try to find you a good example. Yeah. So a 95% confidence interval means that if you were to take 100 different samples with a 95% confidence interval, then approximately 95 of the 100 confidence intervals will contain the true mean value, which is mu. Like I said, if you want to read about this in more detail, then you can always Google it. And there is, of course, a computation for this as well. But in the industry, typically we follow 95%. That's the reason this is default. So I would suggest that for most of you, you would not need to experiment too much with this. All right, so we click on OK. And as you can see, very nicely in one click, we have all these numbers that have been given. So mean, standard error, median, mode, standard deviation, sample variance, so on and so forth. The interpretation of kurtosis and skewness has been given in the presentation. So this is very simple. You can see that skewness refers to positive skew or negative skew, which is where the mean is greater than the mode or the mean is less than the mode. And kurtosis talks about how tall the data set is. So we have leptokurtic, platykurtic, and normal. And as a general rule of thumb, in skewness, we say that a symmetrical distribution is where we have a normal curve and a value under the curve. And if the skewness is less than -1 or greater than +1, we say it is highly skewed. -1, -0.5, 0.5 and 1 is moderately skewed, and -0.5 and 0.5 is approximately symmetric. Depending on what the context is and what the requirement is, you will have to choose this. And in terms of kurtosis again talks about how the tail of the distribution differs. So whether we have extreme values or not. Now, this is quite detailed where we talk about double exponentials and hyperbolic and logistic distributions, but the basic idea here is that the one in black is what we're looking at, which is a normal distribution. And of course, the more you practice with it and when you apply it on your own data, you will understand how this can help you. Something I've left here is standard error, which is not really used that much in the corporate, but I'm sure you can guess from these two numbers how the standard error is calculated. Some homework for you, you can just go and see how the standard error is calculated. All right, so before we wrap up the lecture, let's quickly do one more example. And what we have here is two regions. So we have north and we have south. And what we want to find out here is which region has a better score. Cut to the chase, if I do the average for A and the average for B, it gives us 307 and 286. Interestingly, if we do the standard deviation, we see that the standard deviation is lesser for region south. Again, think of the context. If the total sales is more important, then probably region A is better because it has a higher sale on average. If uniformity is more important, then probably region south is better because the deviation, which is the variation, is a lot lesser. So values are closer together. Think of business applications like stock allocation to different dealers. You do not want a lot of variance because that means that certain dealers have been given higher stock and certain dealers have been given lesser stock. So from an inventory management perspective, keeping the average and the standard deviation together can be really, really useful. Excellent. So that completes our lecture on standard deviation, skewness, kurtosis. And I would suggest that you practice a little bit on your own data and try to see what type of numbers you get before you continue with the next lecture, which is going to be on percentiles, quartiles, and the box and whisker plot. See you for the next lecture.